What do you call a can opener that doesn't work? A cant opener. Ha 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 ha. Second video on the different types of plate margins. We've already done the destructive one. We'll look at constructive today. Just in the same fashion as last time, we will be explaining how earthquakes occur and also how volcanic activity occurs at this plate margin. So, lovely diagram from Mr. Gainsby here from Cool Geography. This is a constructive plate boundary. Again, as a quick recap, you will need to know what a constructive plate boundary looks like. It is where two plates are moving apart from each other. Again, you're going to be asked potentially why volcanoes occur here, possibly why earthquakes occur here as well. I very much doubt they'll ask about fault mountains, but we will cover that anyway. Right, same starting point as always. You need to explain why the plates are moving. So, as per always, the outer core warms the lower mantle, heating the magma, making it less dense. This then rises through the mantle, cooling and spreading when reaching the asthenosphere. This in turn pushes the tectonic plates above it, and obviously that process is called a convection current. In this example, the convection current is going to drive the plates apart. So we'll start with volcanoes. Nice straightforward one compared to the destructive plate boundary, really. Two plates are pulled apart. This then creates a vent. The magma here, remember, is always trapped under pressure. It's constantly rising at this point, as you can see with the convection currents there. Where a vent is created, the magma will rise through that vent. Remember, it's under pressure. You can picture it like a champagne bottle here. If you shake a champagne bottle up, that pressure you can clearly see underneath as the champagne is desperately trying to escape where your cork is holding it in. The same essential idea occurs really with the mantle at any given time. It's always trying to escape. The idea here is as that magma rises up through your asthenosphere, your lithosphere, and actually reaches what would be, actually take it at this point where it reaches the ocean's bed, it then cools and hardens on contact with the colder surface above. Just to point out, when it actually reaches the surface, it becomes lava, technically not magma because it's not underground anymore. And it actually forms a new part of the tectonic plate. So just to repeat that, your magma rises up through the vent due to it being released from pressure, if you will, and as it rises up through it hardens and actually creates a new tectonic plate here, which is the reason why it's called a constructive plate boundary. A series of these type of eruptions occurring can actually build the dried magma or lava up above the surface of the ocean, causing islands to form. A lovely example of that is Iceland is formed in that way. And pretty much that's the reason why a volcano occurs there. The magma is, the pressure is always removed from the magma, if you will. It can rise up through the vent that's created, cools and hardens on the surface. That's pretty much it. The eruptions here are generally less powerful than those that you'd find on a destructive plate boundary, simply because there's like less pressure difference, if you will, on a destructive plate boundary. Remember, you've got the melting of a plate releasing CO2, which rises aggressively through the fissures in the continental plate and then explodes when it's trapped under pressure. With this one, there isn't really a great deal of pressure at these points. It's got quite a smooth run up through here, and as a result, it forms something called a shield volcano, something that I'll cover in a later video lesson. In terms of earthquakes, this is potentially a little bit more confusing. The same starting point as always. Outer core warms the lower mantle, heats the magma, makes it less dense. This then rises through the mantle, cooling and spreading when reaching the asthenosphere. Obviously, as you know, these are called convection currents. This in turn pushes the plates. The earthquakes here are quite frequent, but generally, again, much less powerful, of less magnitude, if you will, than a destructive plate boundary. The rising magma essentially has the ability to crack the seabed as your newly hardened lava up here it has the ability to almost break through that. That causes very small earthquakes to occur. And that's essentially it, really. Your magma rises up through and has the ability to fracture the seabed, but very, very small earthquakes, generally speaking. Iceland would be an example place for this. just the last one, in terms of fold mountains, it's very similar to the destructive plate boundary, really. You've got rising magma up through that literally deforms the continental plate. It can cause this mid-ocean ridge here, the Atlantic mid-ocean ridge, which is largely just a series or a line, if you will, of volcanoes which marks the edge between the North American and the Eurasian plate. It's essentially deformed by the basis of magma rising up through the gap that's created. And that's really it for the constructive plate boundary. Quite a straightforward, simple plate boundary. What you guys need to be aware of is to be able to draw that and talk your way through convection currents and using the correct terms, really, in terms of the vent there for the magma being released up through it. Hopefully that one's straightforward. Come and see me down in H7 if not.